So for my ML project, I have built a fruit recognition system using ANN and PCA. I have used for this I have used Fruit 360 dataset, which are thousands of label images of different fruit. First, I pre-processed all the images by resizing and flattening them. Then I applied PCA to reduce the number of features. This helps speed up training and makes the model more efficient. Then I train this model using artificial network on the PCA transform data to classify the food. I also make a web demo using Streamlight. Here we can select a single image or a zip of images, and in this way it classify the image we have chosen. Thanks.
In this project, I built a machine learning model to classify different fruits from images using random forest. I used three key features: HOG for shape, color histogram for color, and LBP for texture. I experimented with different combinations of these features and trained a random forest classifier for the best results. To make it interactive, I also created a web demo where you can upload any fruit image and the model will predict the real fruit. Thank you.
Hello, I'm Krishna and this is the fruit classifier that I have made using naive Gaussian-based decision theory. Let's have a quick demo. So this is the front end on which I upload the image of an apple. Let's try to classify it, and it works just fine. So how does this happen? Step 1 is feature extraction. These are the three features that I've used to understand my images. Step 2 is PCA and data normalization. This is basically important for data dimensionality reduction. Step 3 is training. Here the model basically finds the means and the variances and the classifiers and stores them all in a pickle file. This is the code snippets for the same. And the final step is classification. Here the model makes a naive Gaussian assumption, but it assumes the features to be independent and having Gaussian distributions. Formula for the same. So for any test image, the class having the maximum of log prior plus log likelihood is chosen as the final prediction. So for my model, the final accuracy came out to be 91.78%. Thank you very much.
I'm Priyanshu Swai, and I use two methods of support vector machine and linear discriminant analysis for fruit classification. Project workflow was dataset preparation followed by image feature extraction, and in the trained various models, evaluated them and did further analysis on the best model. The color histograms were used for color features, LB for texture features, and HOG for shape features. I use Google Cloud Workstation for its fast processing to find the optimal number of LDA components. The quantity results from SVM are that linear outperformed polynomial and RBF, color histogram, and LBP histogram gave the best combination of 98.87% test accuracy. The quantity results from LD and SVM outperformed those of just SVM with 99.2%. Again, the combination of color and LBP histograms. HOG also performed very well with LDA. Further analysis was done using confusion matrix. Thank you.
In this project, I started by resizing fruit images to 50 by 50 pixels to standardize them. I then used principal component analysis or PCA for dimensionality reduction, reducing the dataset from high dimensional pixel values to just 2 and 3 components. Next, I applied k-means clustering with 136 clusters to group similar images together. To optimize memory usage, I processed the images in the batches of 1000 and then set a fixed random state to ensure reproducibility of the result. After clustering, I visualized the results using interactive scatter plot, which clearly showed how the images were grouped based on their color histogram features. Looking ahead, I use silhouette score to assess how well the clusters are defined. Thank you.